Oh, and once again, we are going to do more examples of factoring trinomials when the leading coefficient is not 1. In this video, we're going to do examples where the method we're going to be using is divide and slide. So we're going to be talking about that. So this is a trick that is used to help make factoring easier. So that's the idea behind this. So we're going to do this divide and slide. So the first thing we're going to do, the first thing that you should always do, actually, I don't think I mentioned this before because it hasn't really come up and it doesn't work in this one either, but the first thing you should always do is check and see if there's a greatest common factor that you can factor out. Remember that worksheet that we looked at before that was all factoring out the greatest common factor? You looked at all three and you said, is there anything that these have in common that I can factor out? Well, generally speaking, when you're factoring, that should be your first step. Now, this doesn't have anything in common, right? 3 doesn't go into 14 or so. There's nothing, and it doesn't all have the same variable or anything. So there's nothing that I can factor out of all three. So I can't do that, but later on when we're doing just more general factoring, that's always going to be our first step. So I wanted to mention that here. Once you've done that, then you can go on to the actual factoring. And the nice thing about factoring out the greatest common factor is that it leaves you with a simpler problem. So it's actually really nice when you can factor out a greatest common factor because it leaves you with smaller numbers to deal with, and it's very helpful. So you always want to do that first. Then with divide and slide, the next thing we're going to do, slide and divide, is we're going to slide the 3 over here. So we're going to multiply the front number to the back number, and we're going to rewrite our polynomial. So negative 80 times 3 is negative 240. Negative 240. So now we can solve this like a trinomial that has a leading coefficient of 1. So we're going to be looking for something that multiplies to negative 240 and adds to 14. So if it multiplies to a negative number, then we know that we need to, one of our factors is going to be positive and one of them is going to be negative. And since it adds to a positive number, we know it's the bigger number that's going to be positive. So remember, a negative times a positive gives us a negative. So we know we're going to have one negative, one positive. And the bigger one's going to be the positive one because we want to end up with a positive number here. So I'm looking for factors of 240. Well, 1 and 240 is obviously going to be way too big, so I'm not even going to write that down. The next one is negative 2 and 120, which is also too big. You have negative 3 and 80, still too big. Remember, we're looking for something that adds to 14. So negative 4 and 60 is still too big. Negative 5 and 48, still too big. Negative 6 and 40, still too big. Negative 8 and 30, oops, still too big. Negative 10 and 24, there we go. Right, 24 minus 10 is 14. Those are the factors that we're looking for. So remember, we're factoring this like it's a like it's a trinomial with a leading coefficient of 1. So we can just rewrite it like this. V minus 10, V plus 24. Now remember, this would be this trinomial factored, not this one. So we want to fix it so that it's this one. So in order to do that, that's the divide part of the divide and slide and divide. We're going to divide both of these by 3. Okay, so now we're going to simplify as much as possible. So negative 10 divided by 3 does not simplify, but 24 divided by 3 does, right? 24 divided by 3 is 8. So if I'm simplifying, I get V minus 10 over 3, because that doesn't simplify, and then V plus 8. So the thing that didn't simplify, that is the thing that's going to move here. So sometimes they won't, they'll both only simplify partially. So you'll have to move both denominators because they'll both simplify partially. They'll at least simplify some. Either one side will simplify completely like this and the other side won't simplify at all, or they'll both simplify partially. Those are the two possibilities of what might happen. But once you've simplified, if it doesn't simplify any further, that denominator is going to come up in front. So we end up with 3v minus 10, v plus 8. And this is where that sort of pseudo checking is really important. Is 3v times v 3v squared? Yes, it is. Is negative 10 times 8 negative 80? Yes, it is. We've gotten it back to the right form where it does represent this polynomial and not this one. Their middle terms are the same, but their first and last terms are different. So checking our first and last terms can help make sure that we've gotten back to this polynomial, because this is really a different polynomial that we've just sort of said, well, this one's easier to factor, so let's factor this one and then get it back to this one because we multiplied by 3, and so now we're dividing by 3 and then moving it over here. So that's slide and divide. So let's do one more example of that. One more example. I'm going to go ahead and erase. So we're doing one more example of slide and divide. I kind of like this one. I feel like it's the simplest of all of the tricks that I found. The AC with grouping method is the official way to factor, right? It's the most mathematically correct, if you will. But there are a lot of tricks out there, and some of them are better than others. And I think slide and divide is the best one I've seen. I feel like it makes it's simple and it makes a lot of sense, and you're just simplifying it back down to a kind of factoring that you already know how to do. You're multiplying and then you're dividing, so it makes sense. You multiply, then to get it back to the way it was, you have to divide. So I feel like slide and divide is a good one. But anyway, let's slide. So we're going to do 6 times 25. So 6 times 25 is 150. So we have x squared minus 25x plus 150. Plus 150. So we're looking for something that multiplies to 150 and adds to negative 25. So again, we're looking for something that multiplies to a positive number and adds to a negative number. So if something multiplies to a positive number, then its factors are either going to be both positive or both negative. In order to get them to add to a negative number, they need to both be negative. So both of our factors are going to be negative here. So we're going to have negative factors. So we could have negative 1 and negative 150, but that's clearly too big. I'm going to jump all the way to 5. We get -5 and -30. Otherwise, we're going to end up with a big long list again, and I don't really want to do that. So that's still too big, but it's closer, right? That'll be -35. So we're only 10 off now. So let's see, what else is 150 divisible by? It's divisible by 6. So -6, -25. Close. Again, it's closer, but not quite. 150 is not divisible by 8 or 9, but it is divisible by 10. So it'd be -10 and -15. And there is our -25, right? -10 minus 15 is 25. So these are what we're going to use. So factoring this polynomial here, we get x minus 10, x minus 15. And now we're going to do the dividing part. So we multiplied by 6, so now we have to divide by 6. So we're going to divide by 6. We're going to divide by 6. And then we're going to simplify as much as we can. So we have x minus 10 divided by 6. Well, 2 goes into both of those, right? So 10 divided by 2 gives us 5. 6 divided by 2 gives us 3. So we get 5 over 3. And then in this one, 15 and 6 are both divisible by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So we get x minus 5 over 2. So this is a situation, like I was talking about in the last example, where they both simplified partially. So again, either you're going to have one that simplifies completely and the other one doesn't simplify at all, or you're going to have both of them simplify partially. So those are the two things that can happen. So now that we've simplified, we're going to take our denominators and we're going to move them up here. So we get 3x minus 5, 2x minus 5. And we're going to do that check. So 3x times 2x is 6x squared. That's what we want. -5 times -5 is positive 25. That's what we want. If you don't simplify enough, if, for example, you didn't simplify these, right, and you just moved to the 6's up here, then these numbers would come out wrong when you do that multiplication. Right? If you'd move to the 6's up here, you would get 6x times 6x. Well, that's 36x. That's not 6x squared. That's 36x squared. So if you do that check at the end and you don't get these numbers, then something went wrong in the simplifying part. So you need to check that. Alternatively, maybe you picked the wrong factors. So check that as well. So those are the two places really where things could go wrong, right? Picking your factors, like maybe you just wrote a number wrong, or maybe you added wrong and you picked the wrong factors. That could go wrong. Or it could be in the simplifying. So those are the two main places to check if you want to figure out where you went wrong if your numbers don't work out right. So hopefully that helped. Let me know if you have any questions, and I will see you in the next video.